Hey, this is Mr. James. In this video, we'll be talking about transformations and algebraic maps. So far, we've talked about geometric transformation functions. So those are functions that look like this. Perhaps we are translating with a capital T with the vector maybe 2, -3. We could be maybe reflecting over the x-axis. Okay, that's a geometric function. Or maybe we are rotating around point A 70 degrees, and that'd be counterclockwise. These are all geometric functions. And the reason geometric is because the input and the output of both of them, input and the output, are figures. So those could be points, lines, angles, etc., right? But they're all geometric. On the other hand, in this video I'll talk about algebraic transformation functions. Now these are functions that look like this. We take a coordinate, x, comma, y, and we're going to do something to that. Maybe we will take one of the coordinates and add a certain number. Maybe we'll take another coordinate and multiply by a certain number. Maybe 2 times y. Okay? But in any case, the input and output here aren't figures. We're not explicitly sliding something or flipping something or rotating. No. For an algebraic transformation, our input and output are coordinates. They're coordinates. So whereas for geometric transformation functions, we are literally moving around and sliding, flipping, rotating these figures, these points, these lines. For algebraic transformations, we are working with the coordinates specifically, the numbers like 2, 3 or -7, 5, right? We're working with coordinates there. Now let's see how we can apply some of these algebraic transformations, starting with this first one. We're asked to apply the transformation x, y, so we start with a coordinate, and these arrows, so it's going to x minus 4 and y plus 1. Well, we're not going to be able to do anything with this until we have some coordinates to work with. So let's take a look at this figure here, A, B, C, and write down the coordinates of the vertices. A is at, let's see, 1 in the x direction, -1 in the y direction, so that'll be 1, -1. B, 1, 2 in the x direction, 1, 2, 3 for y, so that's going to be 2, 3. And C, 1, 2, 3 in the x direction, and it's right in the x-axis, so no moving up or down. That'll be at 3, 0. All right, I'll rewrite these points off to the side here with a little bit of space between them. So A was at 1, -1. B was at 2, 3, and C was at 3, 0. Now, what are we doing with these? Well, if we look back over the transformation over here, okay, we can see that I take my original points right here, such as 1, -1. I'll write these in here. 1, -1. And I have to substitute in those values over here. So 1 will go here, -1 will go here. So I have taking 1, -1 and transforming it to whatever 1 minus 4 is and whatever -1 plus 1 is. Let's actually write that off to the side over here so we can get our notation correct. So this is going to 1 minus 4. Again, I started with 1, and this transformation is telling me to subtract 4 from whatever x was. And then -1 plus 1. Again, that's because I started with -1 for y, and this transformation is telling me to add 1. Okay, and so we can simplify this. 1 minus 4 leaves me with -3 for x, and -1 plus 1, well, that's 0. This will be where A prime is on the graph. And so I can go ahead and plot the point for A prime at -3. Let's see, -3, 1, 2, 3, 0, so it'll move up or down. And that is where A prime will be. Go ahead and try to do B and C. Remember, you're taking these points right here, 2, 3, substituting them in for x and y in our transformation right over here. Okay? And then once you simplify that, you can plot the point. Go ahead, try and find the points for B and C. The answers will be up on the screen in 3, 2, 1. And here we are. So again, I've taken these points, B and C, so B is 2, 3, and just substituted 2 and 3 in for x and y in this transformation. So I get 2 minus 4 and 3 plus 1, and that simplifies to negative 2, 4. And I plotted that right here. Same thing with C. I ended up with negative 1, 1, and I plotted that right here. And once you're done, you can go ahead and connect your points to see what the image should be. And it's looking like looks like a translation. So what kind of transformation is this? Looks like this algebraic map actually is the same as if I translated, let's see, 1, 2, 3, 4, so it's negative 4 in the x direction, and up 1 in the y direction, which is quite the coincidence because look at this. Negative 4 plus 1, negative 4 plus 1. Now this is because when we're taking 4 away from whatever our x-coordinate is, we are literally sliding it over 4 to the left. When we're adding 1 in the y direction, it's kind of like going up 1 on the y-axis, right? We're moving it up. So that's why this algebraic function works the same exact way that this geometric function does. They're both translations. Let's move on to the next one. We're going to start the same exact way we started the last one, so let's get up some coordinates right up on the board here. Okay, but this time the transformation doing is a little bit different. When I look at this, x comma y is being mapped to negative x comma y. So that means when I transform this, the point 1 comma negative 1, let's see if I put these in here, 1 and negative 1. Well, that means that my x value is becoming negative. I'm kind of finding the opposite there, so negative 1. But my y value, nothing's being added, nothing's being multiplied, it just stays how it is, so I'll say negative 1. So the point 1 comma negative 1 maps, using this algebraic transformation, to negative 1 comma negative 1. So I'll go ahead and plot that point right here. And there's my A prime. Again, that's A prime. Go ahead, pause the video here, and see if you can find the transformations for B and C, plot those points in the graph, connect to see your image, and then try to answer this last question. What kind of transformation is this? Write your answer using geometric notation. The answers will be up on the screen in 3, 2, please make sure you've paused and tried this one. Make sure you've paused. Here are the answers. And here it is. So basically, we've taken all our points, and the y value has stayed the same, but the x value is switched from positive to negative, or vice versa. And we look at our image right here. What does that look like is happening? What kind of transformation is this? Well, I'm seeing some sort of reflection. I'm seeing a reflection over the y-axis. Okay. If we're being specific, it's actually a reflection over the y-axis of the points A, B, C. So we really should have our input there. Same as over here, right? A, B, C. But that's interesting. Like when I change my x value to negative, like we did up here, it looks like just that little change in the x from a positive to negative takes my entire image and flips it over and creates this reflection. Let's take a look at the next one. Alright, this one here wants us to apply the transformation x comma y goes to y comma negative x. That's a little strange. Let's make sure we have our coordinates down first. There they are. If you need to, pause the video to make sure you have them down. But it's the same image as before, so that shouldn't be too bad. But what's this all about? X comma y goes to y negative x. Well, so let's see. If I'm starting with the points 1, negative 1, it looks like it's flip-flopping the x and the y. So my y will go here, negative 1, and my x will go here. In addition, it says negative x, so that must mean my output is negative 1 here. So let's see. It's telling me to flip the x and the y, because instead of having xy, it's yx. And it's also telling me to make the x negative, or change the sign there. So that means my output here is going to be, let's see, negative 1 comma negative 1. Let's do one more for a second just to get the idea here. So if I had 2, 3, if I had 2 for x and 3 for y, just like I do for b here, then I would put 3, negative 2. 3, negative 2. Okay, I'm flipping the x and the y, and making that x negative. And make sure to finish this out now by yourself. So make sure you get the coordinate for C and plot all the points on the grid. And then try and figure out what kind of transformation is this. Is it reflection, rotation, translation? What's going on when we do this mapping right up here? So go ahead and pause the video. The answers will be up on the screen in 3, 2, 1. And here's our result. It looks like, what's going on here? It looks like when I've plotted all these points, -1, -1, 3, -2, and 0, -3, it looks like this algebraic transformation is making a rotation here, doesn't it, right? I mean, it looks like it's rotating it kind of clockwise around the origin, 90 degrees, I'd say, right? It's not 180, no, but a quarter turn, so that's going to be rotate around 0, 0, and it's 90 degrees clockwise, so I'll have to write that as -90 degrees, and we're moving A, B, and C. Wow, I wonder why this switching the variables, the x and the y, and making the x negative does that. Something to think about. Let's look at this last one here. Apply the transformation. X comma y maps to 2x, 2y. So now we're multiplying x and y by 2. Of course, we need to have our coordinates up on the page, so put those there first. And one last time, I will do A for you. So A, we've got 1 comma -1. And if we plug those in here, 1, -1, and substitute them in, now it's 2 times 1 and 2 times -1. So let's write that over here, 2 times 1 and 2 times -1. And so 2 times 1 is 2, 2 times -1 is -2, and I can go ahead and plot A prime on my graph at 2, let's see, 1, 2, -2, 1, 2, and there's A prime. Go ahead and finish by finding the coordinates for B and C using this algebraic transformation. Remember, we're multiplying both the x and the y variables by 2. Go ahead and pause now. The answers will be up on the screen in 3, 2, make sure you've paused. Here are the 2. For B prime, we've got 4, 6, and for C prime, we've got 6, 0. And look what that's graphed. It's almost like our original triangle ABC has gotten twice as big. It's almost like 2 times bigger. This is not a rigid motion, definitely not a rigid motion. So it's not going to be a translation, a reflection, or a rotation. Not rigid. And actually the name for this is called a dilation, D-I-A-L-A-T-I-O-N. We won't talk about these too much here, but it's interesting to see that we can have algebraic transformations that do things other than rotate, reflect, and translate. Before we wrap up, let's look at the bottom 2 questions. These last 2 questions ask us to work backwards, to write the algebraic map for the transformation that we're given here. So in this first one, we've got a translation, 6, -4. That's in this graph below. Or over here, we've got a reflection over y equals -x, again in the graph below. So the first and most important thing when we're trying to work backwards is, just like before, to write the coordinates of both the image and the pre-image for both of these. So like x would be at the coordinate -2, comma 3. Go ahead, pause the video here, and try and write the coordinates for all the points in both of these 2 problems. Go ahead and pause the video. The answers will be up in 3, 2. Did you actually write in all those points? Please make sure you do it. Here are the answers. The next step to writing an algebraic map is to take all of our coordinates from the pre-image and the image and write them out very neatly, just like this. You can see that J, in red, the pre-image, was at -4, 2, but J prime, the image, is at 3, -1. Go ahead and finish this list for points X and V, and the other problem for points C, H, and P. When you're done, see if you can notice any patterns between the pre-image in red and the image in blue. Please try this now. Pause the video, and when you're done, the answers will come up in 3, 2, 1. Now we can start to see some patterns here and write out our algebraic map. For this first one, we'll look at x and y separately. For the x's, we go from -4 to 3, -2 to 4, -4 to 3. In every case, it seems like our x value is going up by 6, so we can write x plus 6. For the y's, we've got 2 to -1, 3 to 0, 0 to -3. It looks like our y's are decreasing by 3. And so our algebraic map here, x comma y, goes to x plus 6, y minus 3. For the second one over here, it seems like our x and y values are reversing and both becoming negative. Look at h. 5, 2 goes to -2, -5. And so our map will be y comma x, and both will be negative.